Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today I will show you how to differentiate two functions, which is number one, exponential function, and number two, natural log function. Okay, let's see one by one. Okay, let's begin with exponential function. How to differentiate? Okay, number one. Okay, in general, if they give to you y is equal to exponential of x, okay, y equal to exponential of x, in general, if you want to differentiate any kind of exponential function, okay, dy dx for exponential of x is equal to exponential of x itself. Okay, so this is in general. Another one, if there is a constant y equal to exponential of ax, a is any constant, it can be 2, 3, 5, any number. Okay, in order to differentiate dy over dx, so what we need to do over here is you can apply something like outside and inside. Okay, what does it mean by that? It means that first of all, look what type of function that they are using. Exponential function. We know that when we differentiate exponential function, it will always become itself. So just make it itself first. Exponential of ax as a whole function. Function ax, this is the outside part. Multiply inside, meaning that focus on the power. Differentiate the power. So a is the constant. Ax, when we differentiate ax, we will get constant a only. So basically, we will get ax. So this is in general. If we have any constant given, this is constant is 1. Example number A. Okay, I have y is equal to exponential of 2x. Find dy over dx. So how to find dy over dx? Like I said just now, you can apply this one. Outside, this is the outside, the function itself. Inside, this is the power. So what type of function is this? Exponential function. So differentiate exponential function, we will get itself, e2x. And then this is the outside. Inside, differentiate the power, differentiate the 2x. So we will get 2. So the answer is 2e 2x. So this is the dy over dx. Another one, it also can be like this. Y is equal to exponential of x squared. So how to find the exponential of x squared? Dy over dx. So dy over dx for exponential of x squared. So for this case, like example A, apply the outside. This is the outside, this is the inside. We will do the same thing. So exponential of x squared. So it's going to be exponential of x squared. Multiply by, differentiate the power. The power is x squared. So differentiate x squared, we will get 2x. So make it rearrange. So 2x e x squared. So this is the dy over dx. Another example. What if? Example number C. We have y is equal to exponential of 2x plus 1. How to find dy over dx? So dy over dx for this one, exactly the same like previous example. Use outside and inside. So based on this one, look the function first. This is exponential function. So e 2x plus 1. This is the outside. Inside, differentiate the power. So power is 2x plus 1. So differentiate 2x plus 1, you will get 2. So the answer is 2e 2x plus 1. Another example. What if y is equal to 5e 3x? Now I put the constant before the exponential. Okay. So in order to find dy over dx, so dy over dx for this one, so this constant 5, okay, like in our previous class when I have y equal to 3x squared. So in order for you to find what is dy over dx, this 3 you just multiply with the power right, power go down, power minus 1. So basically this 3 remain at its place because this is constant. So 3 times 6, 3 times 2, 6, then x. Okay, same goes over here. This constant 5 will remain. So remain the constant 5. So differentiate. So 5e 3x will become 5e 3x. Inside, what is the power? Power is 3x. So multiply by, differentiate 3x, multiply by 3. So 5 multiplied by 3, you will get 15e 3x. Another example, if we have like this, y is equal to 2e2x. How to find dy dx for this one? So dy over dx is going to be, so differentiate, so 2e2x, so we will get 2e2x first, multiply by 2. Where do I get this 2 from? Differentiate the power. So over here it will become 2 times 2, so 4e2x. Another example. What if we have like this? Y is equal to exponential of 2x power 3 minus 1. So how to find dy over dx? Same like previous example, use outside inside. So what function is this? Exponential function. So differentiate exponential function, you will get itself first. So e 2x cubed minus 1 multiply, differentiate the power, 2x cubed minus 1. When we differentiate, we will get 6x squared. So rearrange nicely. So the answer is 6x squared exponential of 2x cubed minus 1. Next example. If we have like this, y is equal to 3e x the power of 3. Okay, how to differentiate this one? So dy dx is going to be, so 3e x power 3 multiplied by, differentiate the power, 3 x squared. So this is going to be 3 times 3, 9. So 9x squared e x cubed, like that. Okay, but you must remember, when you want to differentiate exponential function, okay, when you want to differentiate exponential function, you must make sure the first part you just copy whatever function is given. You see, just like this. So this is basically how to differentiate exponential function. Use the outside and inside rule. Next example, how to differentiate natural log. Okay, let's go to the second part, natural log. Okay, example. Okay, let's begin with the basic. Okay, what does my natural log? Y equal to ln x. Okay, so basically, in order we want to differentiate dy over dx for any natural log, so dy over dx for ln x is equal to 1 over x. Okay, it becomes reciprocal. So this is the basic differentiation. What if there is a constant? Constant like this, y equal to ln ax. Okay, this is a constant a. So based on this one, in previous function, which is exponential function, if you notice, I apply the outside and inside. Same goes over here. So what I am going to do is, first, in order to find dy over dx, when the given there is a constant, let's say ln 2x, ln 3x, 5x, or any number. First of all, look, what is the type of function is this? The type of function is ln function. So it always will become the reciprocal, the fraction like this. So becomes 1 over ax, okay, multiply, you can predict this one, multiply the differentiation of this ax, multiply by a. So basically you will get a over ax. If you simplify, you will get 1 over x also. So this is dy over dx. Okay, now be careful. In natural log, some question before you differentiate, you need to apply the properties of log. Okay, if you forgot the properties of log, you can revise back what in chapter log. Okay, example like this. Okay, before we go to the properties of log, let's begin with the simple one. Y equal to ln 5x. Okay, y equal to ln 5x. In order to find dy over dx, so this is a constant, apply like this. So what type of function is this? Ln function. So when you want to differentiate ln function, it will become reciprocal. So ln 5x, it become 1 over 5x. Then multiply, differentiate this, multiply by 5. So simplify, we will get 1 over x. Okay, what if like this? Y equal to, let's say, ln, okay, let's put constant in front here, 5 ln 5x. Okay, 5 ln 5x. Okay, 5 ln 5x. So in order to differentiate this one, as usual, this is the constant. So this is the constant. So the constant remain. So 5 ln 5x. First of all, look, this is the ln function. So the constant remain. So 5 remain over there. So just differentiate the ln 5x. So differentiate ln 5x, you get 1 over 5x. So this 5 is coming from here. Actually, this is 5 multiplied by 1 over 5x. Then multiply by, differentiate this, multiply by 5. So simplify, 5 over x only. So this is the final answer. Okay, now talking about the properties of log. Okay, in case of like this, if you have y is equal to ln x square, ln x square. Okay, when you have ln x square, okay, always remember, before you want to find dy over dx for any time of ln, first of all, what you need to do is you need to simplify the function first. How to simplify this function? Apply the law of logarithm. Okay, when there is a power, so you see I still write y, it's not dy dx yet, so power automatically will go down. So ln x. How do I know? This is the law properties. Okay, the log properties. Okay, so start from here, you can find dy dx. So dy dx becomes, so 2 multiplied by, just differentiate this, ln x becomes 1 over x. So the answer is 2 over x. what happened from here to here? I just apply the log properties. Okay, the log properties, the power must go down. Okay, another example. What if we have something like this? Differentiate y equal to ln square root x plus 1. Square root x plus 1. Okay, so based on this one, always remember when you have the square root, change into power half. X plus 1 power half. If you look over here, there is a power. Simplify. You see, I still write y, not dy dx yet. Simplify. So the power will go down. So half ln x plus 1. No more power. Power will go down. Okay, now start from here. You can differentiate. So dy over dx is equal to half in bracket 1 over x plus 1, then multiply by differentiate x plus 1 is equal to 1. So basically the final answer is this 1 over 2 bracket x plus 1. Another example. Okay, what if we have something like this? Y is equal to ln x, okay, in bracket, over, okay, make a bit, x over x plus 1. Okay, y equal to ln x over x plus 1. So based on this one, before you want to find dy over dx, the first thing that you need to do is simplify using the log properties. So how to simplify? This is the division. Okay, the property said, I will copy the properties first, if just in case you forgot. The property said if you have log a over b, so this is equal to log a minus log b. So this is properties in chapter log. Okay, I will apply these properties in order to simplify this one. So based on this one, so y is equal to, since this is the division, so it becomes ln x minus ln x plus 1. Okay, so ln x minus ln x plus 1. Start from here, you can do the differentiation, dy over dx, one by one, part by part. The first part, ln x becomes 1 over x, minus the second part, 1 over x plus 1. So this is your final answer, dy over dx. So that's why always remember, for natural log, apply the properties of log first before you find the dy over dx. Next example, let's have a more example. For this natural log, okay, if you want to differentiate, it is recommended for you to revise all the properties of log in previous chapter, in chapter log. Okay, you revise the properties of log first, and then you try to do this type of question. Okay, next, another example. What number just now? Okay, let's say number 6. If we have y equal to ln, let's say x in bracket x plus 1 square. This time I have 2x. Okay, the solution. How to find dy dx for this case? Okay, first of all, do not differentiate right away for the natural log. What you need to do is apply the rule first. So this is the multiplication rule. The multiplication rule said that if you have log AB, A multiplied by B, this is equal to log A plus log B. Just in case if you forgot. Okay, so this is the properties. So I will split this into two. So y is equal to ln x plus ln in bracket x plus 1 squared. Can I differentiate right now? Not yet. You have the power. So y is equal to ln x plus, bring down the power, 2 ln x plus 1. Okay, now start from here, you can do the dy over dx. Look the way I write, okay? This is y, now dy over dx. You need to follow, okay? So differentiate part by part. So differentiate ln x first, become 1 over x. So differentiate the second part. So 2 multiplied by, differentiate this, ln x plus 1, 1 over x plus 1. So 1 over x plus 2 over x plus 1. So this is the differentiation of question number 6. What if we have something like this? Y is equal to ln x square in bracket x plus 1 the power of 3. Okay, make it divide x minus 2. Okay, interesting. Okay, now more complicated, but actually it's not complicated. How to find dy over dx for this case? What you need to do is simplify first. Okay, simplify first. Okay, now I have multiplication, I have division. So how to simplify? So simplify the top part first. So ln x square plus ln x plus 1 over 3. Y plus, because this is multiplication. Then divide minus ln x minus 2 in bracket. Can we do the dy over the x right now? Not yet. Power. So y is equal to 2 ln x plus 3 ln x plus 1 minus ln x minus 2. Can we do the dy over the x right now? Yes, you can. So what is dy over dx? So dy over dx, differentiate part by part. So 2 ln x, you will get 2 multiplied by 1 over x. So 2 over x plus, how about this one? 3 over x plus 1 minus, how about this one? 1 over x minus 2. So this is our dy over dx. Okay, any question you can ask me. Okay, you can text me. So we continue in our next video. So that's all for today. Thank you.